This video is on chapter 1, homework 6, 1-68 to 1-72. On this first section, we are dealing with laws of exponents. So just a little reminder, if I have x to the a times x to the b, I would add the exponents and I get x to the a plus b, okay? Notice again, same base. If I had x to the a raised to the power b, power to power I multiply and I get x to the a times b. If I had x to the a divided by x to the b, I'm going to take x to the a minus b, always top minus bottom, and that's going to be my answer. Couple other things to remember, that x to the power 0 is always 1. Something else to remember, if you have x to the negative m, that's going to be the same as 1 over x to the positive m. So that's something else we want to remember. So we'll be using these ideas while we are working out 1-68. On the first problem, what we're going to do is I have 11 h's multiplying on top, 9 multiplying on bottom. It's going to be x to the 11 minus 9, or h to the second. Okay, I'm going to have 9 cancel from top and bottom, leaving me with 2 on top. The next one, I'm going to add the exponents. I'm going to take x to the 3 plus 4, so that's going to be x to the 7th. On C, everything in that exponent is going to be raised to the second power. So 3 is going to be raised to the second, and my k to the 5th is being raised to the second. So what happens is 3 squared is 9. K to the 5th raised to the power 2, power to power I multiply, and I get 9k to the 10th as my answer. On the next set, what I want to remember first off is this n is really n to the first. So this is going to be n to the 7 plus 1, or n to the 8th. On number 2, I'm going to be paying attention to different pieces of this. My 16 over 2, my x to the 4th over x to the 4th, and then my y to the 3rd, okay? So when I have 16 over 2, that is 16 divided by 2, that's going to be an 8. My x to the 4th over x to the 4th, those are going to cancel each other out. And I'm going to be left with y to the 3rd. So I'm going to get 8 y to the 3rd. On letter F, I am going to be multiplying the 4 and the 7 together. I'm going to be looking at the x and the x to the 2nd. I'm going to be looking at the y to the 3rd and the y to the 3rd. So when I do this, 4 times 7 is 28. X times x to the 2nd, I'm going to add those exponents. It's going to become x to the 3rd. Y to the 3rd times y to the 3rd, that's going to be y to the 3 plus 3, or 6. And that's going to be our answer. On 1-69, so Haley simplified x to the 3rd times x to the 2nd, and she got x to the 5th. That's Haley. Lacey simplified x to the 3rd plus x to the 2nd and got the same result. However, their teacher told them that once simplification is correct, who simplified it correctly, and how do you know? So the person who did it correctly was Haley. Okay, Haley did do it correctly, because if I take x to the third times x to the second, and if I was to expand this, this x to the third would be x times x times x. This x to the second would be x times x. When you're looking at this, the total of them that I ended up with is 5, so this would be x to the fifth. If you were to take x to the third and add it with x to the second, you are not going to be getting x to the fifth. You cannot add unlike things. You cannot add unlike things. So Haley is correct. Now on number 2, Haley simplifies 3 to the 5th and 4 to the 5th and gets 12 to the 10th, but Lacey's not sure. So we want to see, is that true? Does 3 to the 5th times 4 to the 5th equal 12 to the 10th? Okay. Well, 3 to the 5th times 3 to the 4th, I would have 1, 2, 3, 4, 5 threes. I would have 1, 2, 3, 4, 5 fours. Now, what's going to happen here is every one of these, this 3 and 4 is going to be a 12. This other 3 and 4 is going to become a 12. Let me just kind of move this. This 3 and 4 is going to make a 12. This 3 and 4. So what's going to happen is, as I'm matching each of these, I'm going to end up with 12 to the 5th, not 12 to the 10th. On number 71. Okay, so we don't know what the function is, but we know that that function is equal to 9. And we want to figure out what is happening here. So everywhere I see an f of x, okay, everywhere I see an f of x, everywhere I see an f of x, in place of that, I'm going to put a 9. So in place of this, I'm going to put a 9. In place of this, I'm going to put a 9. In place of this, I'm going to put a 9. So f of x plus 3, when f of x is 9, 9 plus 3 is 12. That's my answer. 2 times f of x, well, f of x is 9, so if I have 2 times f of x, I really have 2 times 9, which is 18. And then for C, I have 3 more than 2 times 9. Well, 2 times 9 was 18. I'm adding 3 onto that, so I'm going to get 21. On 72, we're solving. So let me just kind of draw my line where my equal is. Don't have to do this. I'm just going to try to do this to emphasize both sides of my equal. Okay, so on the first one, I would personally deal with my x's first. So I'm going to add x to both sides. And when I do, I'm going to get 4x plus 7 is equal to -1. I need to be careful about that. Then I'm going to minus 7. And I get 4x is equal to -8. And then I'm going to divide by 4. And when I do, I'm going to get x is equal to -2. On B, first off, I noticed that on this side, I can clean up some things. That 1 and 5 is going to make a 6. So this is really 6 minus 2x is equal to 4x minus 3. Now, I'm personally going to deal with my x's first. So I'm going to add 2x to both sides. I'm going to get 6 is equal to 6x minus 3. I'm going to add 3 to both sides. And I get 9 is equal to 6x. I'm going to divide by 6. I'm going to divide by 6. And when I do, I'm going to get 9 over 6 is equal to x. Or I can simplify that because I can divide top and bottom by 3 and get 3/2. On letter C, I am going to clean up this side of the equal by combining like terms. And my 4x and my x is going to give me a 5x minus 2 is equal to a negative 2x plus 2. I am going to deal with my x's first. I'm going to minus 2x from both sides. I'm going to get 3x minus 2 is equal to negative 2. I am going to add 2 to both sides. And I'm going to get 3x is equal to 0. And this is where you want to be careful. This is not no solution. I'm going to divide this side by 3. I'm going to divide this side by 3. And when I divide 0 by 3, I get x is equal to 0. That is my answer. On D, I'm going to clean up this side. And I'm going to clean up this side. So on the left-hand side, my 3x, my minus 4, my plus 1, I'm going to get a 3x minus 3 when I combine like terms. On the other side, my negative 2x, my positive 5x is going to become a 3x minus 5. Now, some of us might notice right away that I have a 3x on one side and I have a 3x on the other side, that those are going to cancel out. And I'm going to be left with a negative 3 and a negative 5, which are not going to be equal. Some of us may not have seen that right away, but when you subtract 3x from both sides, you are going to end up getting negative 3 is equal to negative 5. That is false. That's going to be no solution. On these ones, they're asking us to simplify. This is going to be x to the, I'm going to add the exponents, a plus b. On b, I'm going to go power to power, so that's going to be x to the ab. On c, I'm going to subtract my powers, so it's going to be x to the a minus b. Now, this one, my 2 is going to be raised to the power a, my x is going to be raised to the power a, and then I still had x to the b. So 2 to the a is going to be 2a, x to the a, b to the a. I'm sorry, x to the a, x to the b. Now I can clean this up because these are the same base. So this is going to be 2 to the a, x to the a plus b. And that will be my final answer. And that's the end of this video.